Hi, I'm James McGuire, and on today's eSpeaks, we're talking about data management and how problems with data management create a challenge for a company's success with artificial intelligence. There's a new survey of 600 global executives that addresses these topics, and we'll talk about the findings. To discuss that, I'm joined by Chris D'Agostino, Global Field CTO of Databricks. Chris, very good to have you with us today.
Hi, Jamie. Nice to see you. Thanks for having me on eSpeaks.
And I like your background. You were on the road today, Chris? Are you just traveling?
Yeah, I'm in Syracuse, New York, visiting my son, who's a freshman here.
Fantastic. There's an adventure for you.
Yeah.
I know there's a really interesting survey. I want to get to that, but let's get a sort of a nutshell of what Databricks does. What is Databricks?
So Databricks is a data and AI platform that's a SaaS-based solution. We run in all three major cloud providers, GCP, Azure, AWS, and we provide a data and AI platform that allows customers to add their data into the environment and do a whole suite of analytics, everything from data curation and ETL to data warehousing, as well as machine learning.
Interesting. Definitely a market for that these days. All right, so there's this really interesting survey that addresses just those kind of things. I've got some bullet points I'd like to ask you about, but before we get to the specific points, is there a major takeaway about AI and data management, or another topic that you take away from the survey?
Yeah, absolutely. You know, what's sort of undeniable in the survey is that most executives see AI as paramount to the success of their business. But along with that comes a suite of challenges, or a set of challenges regarding the data that they're processing. And it's no secret in industry that the more data that you have and the higher quality that data is, the better off you are in terms of building out reliable production-ready machine learning models. And so our platform is really designed to help companies get there faster.
Well, and of course and you talked about, so there's the data prep. Data prep, I hear, is a really critical element of that process.
Oh, for sure, right? You've got in large enterprises, you have somewhere near 1,000 production systems in some big enterprises that are generating data that needs to be brought together, oftentimes merged to create, say, a 360-degree view of a customer. Those data systems have different file formats and different shape to the structure of the data. So the ability to pull that data in, to massage it and get it set up so that you can examine it with either data warehouse technologies that are built into Databricks, or through machine learning algorithms and building and training models, that data curation step is really critical.
Mm-hmm. All right, well, let's go to the survey. Some neat stuff here. So here's a bullet point from the survey, and I'll quote this. Well over half of executives expect AI use to be widespread or critical in business functions by 2025. From that, I take, correct me if I'm wrong, that AI is still closer to not quite mainstream yet here in 2022. What's your view on this?
Yeah, you know, it's interesting. The company, I think when it was founded, made three real big bets when it was founded, nearly 10 years ago. And that was organizations would move to the cloud to run their enterprises. The second was that they would rely more heavily on open source software. And then the third was that they would really move towards AI as sort of the first approach at dealing with data. Moving to the cloud has taken some time. There's lots of early adopters and very successful companies out there. There are ones that are, taking a more cautious approach by kind of this hybrid, moving some of their data workloads into the cloud, keeping some of them on-prem. The move towards open source has been undeniable as well. So adoption of AI and getting the right types of machine learning models into production, especially at scale, is kind of that last mile, if you will. And so we think companies, especially as they adopt the cloud technologies and are able to run, say, our platform, for example, they're going to move there more quickly. But getting good quality data and the data governance around it, the model risk governance, ethics in AI, explainability, all these things become very important topics.
Mm-hmm. Yeah, explainability and the ethics picture it seems like it's growing in importance. All right, here's another bullet point from the survey. 72% of C-level respondents stress that problems with data management will jeopardize future AI achievement. I'm almost surprised that number isn't higher than 72%. I think there's going to be plenty of problems with data management and in a struggle with AI achievement. What is your view on that?
Yeah, Google had published a research paper that said the unreasonable effectiveness of data, which basically said a large volume of good quality data with a less sophisticated model will outperform a really sophisticated model with poorer quality data. And so, organizations are oftentimes investing heavily in data science teams and machine learning teams, and we welcome that. We're really here to sort of create data as a team sport, and that's a key role within that team concept. But focusing on the data and ensuring that the data is of high quality, the best quality possible, ensuring that you are able to train models and look for bias in the underlying data and sort of root that out. These are really critical things. So the data management piece of it, and being, as you think about organizations collecting petabytes of data, human beings are not going to be able to keep pace with analyzing that data themselves to see if it's of good quality or to look for bias. So you really need to be able to have a platform that allows you to set the parameters around what constitutes good data in terms of schema enforcement, data quality checks, be able to run algorithms against the data itself to see whether or not the data might be biased in some way or differs from previous versions of the same data source. And then I think finally it comes down to cataloging that data in a way that users can discover it, because at the end of the day, if you're going to build any type of algorithm or model, or you're going to execute some sort of business decision, knowing what data assets sit within your overall data platform is really critical to get there.
Something you said there is really interesting. You talked about the idea of data as a team sport, which I think is very much the trend of what's happening, and that the idea of the democratization of technology, the democratization of data, and that at some point only the C-suite had access to the magic numbers, the magic data analytics numbers. But as we move forward with data, it feels like that's filtering down to the mid-level, to into the cubicle workers. Talk to me, if you will, a little bit as a sidetrack, but I think it's interesting. What do you mean about data as a team sport, and in what way does Databricks enable that?
Yeah, so a couple of points come to mind. The first is that in more traditional data processing environments, if you roll the clock back a few years, what you saw was fit for purpose systems that would work on the data for the given use case, right? You had Hadoop for a lot of the machine learning use cases. You'd have SAS for the statistical analysis. You might have a data warehouse for all of the SQL-based queries and data marts and things like that. And the spirit was the same. Everybody was trying to get value out of the data, but they needed to do it with different tooling and with, unfortunately, multiple copies of the same data, which increases the risk in data governance and data compliance to an organization. So when we think about data as a team sport, our goal is to bring those different personas together and allow them to natively work in the programming languages that they're most comfortable with. So Databricks was founded by the creators of Apache Spark. Spark supports all the different major programming languages: Java, Scala, Python, R, you name it, SQL, of course. You can program in the language of your choice, but you're doing it against one copy and one view of the data. And so the team sport concept here is, if you can collaborate with those different personas that have a different objective in terms of perhaps a different insight that they're trying to get from the data, instead of them needing 3 copies of the data to do it, with those, the data engineer, the data scientist, and the data analyst, you actually are just working with 1 copy of the data, all against that same view of it. And any improvements to the data that's done by one team benefits the other teams downstream.
Well, and if I hear a lot about that, not needing to copy data and the power of that. Is that because, say, for example, a team in Hong Kong is going to work with a team in Seattle, and they're even on different, physical hardware platforms? Is it a question of the data is being virtualized, or is it a question of Databricks allows access to that one pool of data in some way? Like how can it not be copied?
Yeah, I mean, in some, like the example that you just gave, if you were genuinely running data teams against different infrastructure platform, like let's say GCP versus AWS.
Right.
In that example, you're going to need whatever data that the team in Seattle needs in order to run its workloads will have to be resident in, let's say, AWS in that environment, for example. Mm-hmm. So we're not saying you're not going to copy data at all. Within a platform, within that environment, you're going to, within a single cloud provider, you can have one copy and one view of that data for the teams that are operating against that. But you raise an interesting point. Databricks is able to sit on top of all the major cloud providers and give a consistent user experience between them. So if you did have teams that were working in Hong Kong, and let's say they were on GCP, and in Seattle working on AWS, the cool thing about the Databricks platform is we're not asking you to learn a whole new set of tools. If you look at the cloud providers, the hyperscalers, they offer some very great infrastructure as a service, and they offer some really great data tooling. But if you're an organization that's multi-cloud, and when we do our research, we're finding that 80% of large enterprises are already multi-cloud, you don't need to teach and train your individual users and your data teams to work with, different tools on GCP and different tools on AWS. They can use Databricks, one single user experience that's consistent across those cloud providers. And as I said, in your example, you would have data sitting in two environments, but Unity Catalog, which is our way of really categorizing and cataloging data assets inside of an organization, it would be able to see the data holdings of each.
Interesting. All right. All right. So back to a bullet point. Here's from the survey. 78% of surveyed executives say scaling AI successfully is top priority for data strategy. I would not quibble with that. What's your take on that?
Yeah, you see a lot of organizations be reasonably successful, if not very successful, with a few models, maybe in the tens, dozens of models, perhaps. We see some very successful organizations using our platform that have thousands of models in production. And when you think about the, you've heard the term DevOps in the development lifecycle of being able to write code and deploy it reliably and have that deployment pipeline. The same concepts are true inside of machine learning. When you think about the process of developing a model and being able to do that at scale inside of an organization, where you can look at the most raw format of data as it's created, and then be able to do all the feature engineering that you need to create a model, and then bundle that model up, run it through some kind of review to ensure compliance and the governance pieces, and then deploy it into production. That process is really hard to get right, and organizations struggle with it. So that's why you tend to see so few that actually get to scale. So what we're hoping to achieve is provide, an opinionated point of view on how you do that model ops, the machine learning ops, and that model lifecycle governance, and actually get these models into production more quickly.
All right, this one I find pretty surprising is a bullet point from the survey. AI investment will be strongest in financial services. The thing I feel somewhat surprised about that is that I think about the two sectors that have been slowest to adopt cloud is healthcare and financial services, partially for compliance reasons. Yeah. And I think not that many people are going to really invest heavily in AI without also investing heavily in the cloud because they're so intertwined. So what does it mean that AI investment will be strongest in financial services?
Yeah, so one, they're organizations that tend to have the financial firepower to do so, right? So they hire. I come from a financial services background. Prior to Databricks, I was at Capital One. We made massive investments in the data engineering, the data transformation initiative, and the machine learning platforms. So one, the organizations tend to have the financial resources to do so. Right. You're right, though. They tend to be conservative with moving to the cloud, and they want to make sure they do so in a really stepwise manner, in a way that the data governance pieces are really kept in place. Because with GDPR, CCPA, all of the regulatory compliance around financial services, you can't afford to make a mistake in terms of the data governance. The nice thing about Databricks is it's built on top of very successful open source projects, many of which we created and have curated the community around them. In one case, we acquired a company that had a very popular open source visualization tool called Redash. But we do see some customers of ours, as they move workloads from on-prem into the cloud, they're using Databricks to do the data science and data warehousing work there. But they also then leverage the open source version of the underlying tools or components that make up the Databricks platform. So they can kind of get the best of both worlds, do some things around AI that for the data that sits on-prem, and then of course, take advantage of all the benefits of the Databricks platform when they move some of those data workloads into the cloud.
Okay. Last bullet point from the survey. Executives see multi-cloud and open standards as integral to AI progress. I can certainly believe that. I think maybe there's an executive out there who's thinking, oh goodness, I'm really concerned about the security things, and I get really nervous with open standards, although many people love them, because I want everything to be a closed, shut tight ecosystem. What do you say?
Yeah, so I try to separate out security and securing a platform from the objective and the principle around open standards and transparency. I personally believe if you've got open source software as a fundamental component of your platform, you've got many, many more eyes on the underlying source code. And so, you could have proprietary systems that get hacked or have some kind of security flaw in them, and nobody can see the code except for the vendor themselves. What we like to do is, as I said, we've built our platform on top of these open source projects. So we've got a lot of eyeballs on the source code from around the world and people, looking for security issues and things like that. At Databricks, we take those open source projects, we further enhance them in terms of performance. We also do a lot of security additions to them to make sure that that's really, locked down very tight. So for us, we love the idea of the openness. We love the idea of the transparency, but it's secure at the same time. In the cloud, you get into the cloud environments and there's lots of knobs to turn for security. And so one of the things that we do for our customers with the platform is we abstract that away. We handle all of the underlying cloud security on their behalf. And so if you can think about it, you're kind of getting the best of both worlds. They're getting the openness and open standards so that they don't get locked into a particular vendor, including us. All of the data that sits in Databricks as a platform adheres to open formats and things like that. So the end customer could take their data and go to another platform or do something else with it if for some reason Databricks wasn't meeting their needs. But then at the same time, it's very secure because we have a very strong security team at Databricks investing lots and lots of money in hardening the platform and making sure that it's airtight.
You've talked about this. You surely talked about the Databricks Advantage, a lot of interesting stuff. I'm interested specifically, what sets Databricks aside, apart in terms of addressing AI and data management? Is there some singular advantage? What is the Databricks Advantage in short?
Yeah, I think the key thing for us is we've always wanted organizations, customers to have optionality with their data. And so our approach has been, instead of persisting the data inside of the Databricks Lakehouse architecture, which for us, that's combining the data lake construct with the data warehousing construct into one platform and letting you run those workloads against, whether it's data engineering or it's SQL-based reporting, all of that can be done in one platform, which we describe as the Lakehouse. What sets us apart, though, is that all of the data is persisted in the very low-cost object stores of the major cloud providers. So if you think about an organization with a petabyte of data, the cheapest way to persist that data, forget Databricks, forget any vendor for a moment, the cheapest way to persist that data is to store that data in the object store of a cloud provider, whether it's ADLS Gen 2, it's S3 at Amazon, whatever, GCS, whatever cloud provider you choose, because the ingress and egress costs are incredibly low, right? Pennies, for gigabytes of data. So if you start with that as the foundation, and then you layer on the idea that you're going to have open standards for the file format so that they're not proprietary and locked in, then you've got this compute engine that needs to run on top of it. Right. And what I like to remind data executives about is that every time you lift data off of storage and run it through a network connection into memory on a server and then run some compute against it, that's costing you time and money. So if you can choose a platform that has the built-in capabilities of things that I mentioned earlier, like schema enforcement, data quality checks, tracing the lineage, the ability to merge data sets in a very low cost way. If you can have that compute engine do that very efficiently, you're keeping your costs as low as possible with the overall platform. So total cost of ownership goes down, risk goes down because you've got that one copy of data that all the team members, the team sport concept again, can operate against.
It's interesting. Yeah, I mean, I think there's sort of an irony there in terms of the marketplace, and that Databricks is cloud agnostic, and of course there's the hyperscalers themselves who would like to go after some of those customers, but of course each of the hyperscalers is not cloud agnostic. AWS loves AWS, but of course Databricks can be cloud agnostic. I don't know what my point is. I just find it to be really interesting.
Well, I think another thing that your audience might find interesting, if they don't know already, is the fact that all three cloud providers are investors in Databricks. So, we're a privately held company, have goals of going public at some point. The objective, though, was we want to partner very closely with each of these cloud providers, because at the end of the day, the Databricks platform running in each of these cloud providers' environments generates a lot of revenue for the underlying hyperscaler, because there are compute nodes that spin up that are running the Databricks platform, of course, and that generates revenue. We again come back to that concept of, as a team sport, it's better to be consistent with the user experience and get people trained really well on how to leverage the tooling associated with Databricks than for them in a multi-cloud environment to learn the individual tools within those other cloud providers.
Right. That is a critical element, because then it's easier for the individual staff member. That individual doesn't need to learn 3, 4, 5 sets of tools, of course.
That's right.
All right. I think the big question is the future. I mean, that is the $1 zillion question, is, the future of data and AI management. That's a question that serious people are sitting right now thinking about and spending enormous amounts of money on. What do you see? Some key milestones? What do you see when you look ahead to the middle of this century? We're almost there. Middle of this decade, excuse me. In terms of milestones for the future of data and AI management?
Yeah, so we created an open source project called ML Flow, which was our point of view on how you can do the ML ops type stuff that we talked about earlier in terms of feature engineering, model development, model deployment. We touched on it a bit. Explainability, ethics in AI are really huge topics, and we've got some thought leadership pieces around that. The data governance piece, it ties all back to, the quality of the data. Can you inventory properly the data assets that you hold? When we get to runtime environments, understanding how models are performing and what models are drifting from the intended training and sort of performance characteristics, being able to retrain those models with new data. Data upstream, as it feeds into the platform, oftentimes changes, so the shape of it changes. You need to be able to dynamically adjust to that. So we are thinking about that full life cycle of build the model, run it in production, monitor its performance, understand when the incoming data is changing, and get the teams to be able to adjust those models very quickly. So again, it's that turnaround time of concept of how an AI use case could be solved to production, shortening that down from oftentimes many months down to a number of weeks at most.
All right. Well, last question. I've been thinking about this topic. What about the relationship between artificial intelligence and cloud in the years ahead? I mean, it seems like those two technologies are really intertwined. This is a big question. That's probably a 6-hour question. There may be no real answer to it, but I'm just wondering, the relationship between cloud and AI, they're going to drive each other. They're going to not drive each other. What makes sense there to you? What would you say about the future of these, how those two technologies are intertwined?
Well, I think, if you look at it from cloud enabling the development of AI, then
Right.
you look at it from the perspective of, okay, you can dynamically scale up environments, and you can train vast amounts of data, models using vast amounts of data at a relatively low cost, right? You can then flip it a bit and say, can AI start driving the cloud?
Right.
Meaning, instead of in an a priori way, really looking for, writing the algorithms to detect the presence of a social security number in a data file somewhere, what about the AI driving the detection itself, right? So AI kicking in and knowing that data has changed, or, hey, this bit of data looks inconsistent with earlier versions of the same data, the data source. Those are the kinds of things that we think are going to really go into high gear in the future.
Mm-hmm. Well, it seems like the other way that AI will drive the cloud is that AI, as we've talked about, requires an enormous reservoir of data. And so where are you going to store all that data? And the question, it has to be in the cloud. So it's as AI rises, the need for the cloud coincidentally rises.
Yeah, I mean, you're spot on. Our architecture has this concept, it's called the medallion architecture, and it has this concept of bronze, silver, and gold level data. So in our minds, data coming in from the source systems in its rawest format is in its bronze state. And that raw format is where the data science teams have the most power, because they can do a lot of experimentation around that feature engineering and model development. But that data is massive, right? And then if you think about sort of paring it down as it goes from bronze to silver to gold, and you're improving its quality, maybe you're merging data sets to create that 360-degree view of a customer, you still have this massive amount of data that you have to keep track of. And so that storage requirement, I don't think is going to go away. And I think as organizations add more and more data, it's just going to become even more critical for the cloud to be, the underlying sort of backbone for all of this.
Chris, I think you said it. Fascinating. I learned a ton. Thanks so much for sharing your insight today.
Thanks, Jamie. I appreciate you having me on.